Hi friends, this is Syed Reshma Sharif. In this video lecture today I am going to discuss about a radar range equation. Okay, here I have a radar system. This is the radar system. Here I have a radar system which has got trained to identify the range of the target. This is range. This is the target. This is the antenna. Okay, here we have to identify the range of the target. Over here, in this I will be going to derive few equations which is based on the range of the radar. Okay, which is based upon this range I am going to derive some equations. So if I say the radar is transmitting some of its transmitted signals, okay, towards the target. Okay, here what this transmitter or receiver antenna do here? Transmitter antenna, it transmits the signals. However, the signals that travels up to a distance towards the target. So here, what will be the power density by isotropic source? That will be power density by isotropic source, that will be is equal to P T by 4 pi r square. What I say here, the gain of the antenna is G. Here there is a gain. This is gain. This is the gain of the antenna, that is G. That is equal to PT by 4 pi r square into G. If the gain of the antenna is in the direction towards the target is G, so then the power density will be this one. Pt by 4 pi r square into its gain. Okay. Now what happens? It is the signal that is getting travel towards the target. This is the signal. Here, this is the signal that is getting traveled towards the target. Based on the target area, it will say that the target area is psi. This is target area. Okay. Then the power reflected by the target will be power density into target area. Where the target area is psi is sigma, then the power at a target, that will be a power density of a target that equal to Target area is sigma. Based upon this, the power density into area of the target, it will be is equal to P T by 4 pi r square into G into sigma. Okay. Now what happened? It is the power which is coming at the target again. We are transmitting some of the signal, isn't it? We are transmitting some of the signals over here. These are transmitting signal. From again, the signals are reflected back from the target like this. Okay, coming from the target again, it will get be reflected by the target. The power which is coming at the target, again the power will be get reflected by the target. Once again I am repeating this sentence. Listen. The power which is coming from the target, again it will reflected back by the target. The power which that coming at the target, again the power will be reflected by the target. That power will be come at the radar system. The total power that which is coming from the target that reaches to the radar system. So we can calculate power density of the reflected power at radar system. That reflected power density of radar system is that will be that power which we have recently calculated into 1 by 4 pi r square. So that's why the reason the area covered by the reflected area at a distance of r will be 4 pi r square. What is this? This is the area at a distance of r which is covered by the reflected area. The power density by the reflected area will be by reflected signal is equal to PT G sigma by 4 pi r square into 1 by 4 pi r square. That is equal to PT G sigma by 4 pi r square whole square. Okay. Now if I say the effective area, see here, the effective area is here. Effective area of the receiving antenna, that is AE. Again here this antenna is receiving antenna, isn't it? So the effective area of this receiving antenna is AE. Then the effective area of antenna AE received power is effective area of antenna the received power PR is equal to PT G sigma AE, that is the area of effective area of its antenna, by 4 pi r square whole square. It will be a reflected power. Okay, what is this? It will be a reflected power. Now, if I want to calculate maximum range of the radar, in that case, the received signal will be minimum. If you calculate the maximum range of the radar, in this case, the received signal will be minimum. If you calculate maximum, automatically the reflected signal or the received signal will be minimum. So, if I say this range of the target is maximum, in this case, the receiving signal is minimum. Detectable signal to the radar systems. For maximum range, R max, received signal is minimum. This is called as a detectable signal, that is PR is equal to S minimum, signal which is received is minimum signal. From that we can say that minimum detectable signal S minimum is equal to S minimum is equal to PT G sigma AR by 4 pi whole square into R max per 4, where R square whole square. Okay, R power 4. Here we are taking R as a maximum received signal, which is maximum. Here R max, it is for receiving signal. For maximum range, the received signal is minimum. For minimum range, the received signal is maximum. Okay, from that we can have the maximum range equation. R max is equal to PT G sigma AE by 4 pi whole square S minimum whole power 1 by 4. This is what radar range equation. This is a radar range equation. Now, if I want to calculate furthermore derivations regarding this radar range equation, in this case we can use this trans receiver antenna for radar system with parabolic antenna. Here we are taking this antenna as a trans receiving antenna. Here replacing this antenna with a parabolic antenna, and with the parabolic antenna, for parabolic antenna, for parabolic antenna, gain G is equal to four pi AE by lambda square. Okay, hence where R maximum, maximum range equation R max is equal to, here we gain for every antenna it has its own gain. So we are replacing here gain with 4 pi AE by lambda square. Then the maximum range equation will be PT. Here gain we are replacing with 4 pi AE by lambda square sigma AE by 4 pi whole square S minimum whole power 1 by 4. Okay, here 4 pi and 4 pi get calculated, then the equation will we get is R max is equal to PT, here AE here AE square sigma by 4 pi lambda square S minimum, here 1 by 4. This is radar range equation. This is a radar range equation. It is very useful for different parameters. For calculating different parameters, this radar range equation will be useful. It is depending upon and how we should design the radar system so that the radar system can have the maximum range. Our main target is to be that radar must be in a maximum range. Once again, in this lecture, we already calculated totally about power gain, effective area of antenna, receiving power, reflected power, power density by reflected signal, maximum range equation, and also maximum range equation by taking parabolic antenna. If you have any doubts regarding this entire radar range equation, you can comment me on my comment section. I will give a brief explanation again. Okay. Thank you for your watching. Please like, share and subscribe to my channel.